Hello, everybody. My name is Sarah, aka Dr. G, and I'm excited to be here today. You might be coming to us or watching us on a YouTube channel or on Learn TV or on the Twitch channel. If you're here from the Microsoft reactors, hello, welcome. And today I am very excited because this episode of Learn with Dr. G is going to be talking about two of my favorite things in the whole world. One is space exploration, because who doesn't love that? And the other is animated films. I just love that music. It makes me so happy every time. I wanted to let you know that I will be checking out the Twitch channel chat. So if you do have questions, hello, I'm in the chat here. So feel free to ask me any questions that you might have, and I will be checking in on that. This is my first time doing kind of streaming to multiple places. So if it's a little wonky and slow, sorry about that, as in me being slow. Sorry about that. I'm trying to kind of keep up with everything. All right, so today I'm super excited, like I mentioned, and we've got a couple of things. So if you missed the last couple of episodes of Learn with Dr. G, basically I introduced the inspiration for what we're going to explore today. The Netflix original film, Over the Moon. It came out last Friday, which is October 23rd, if you're not watching this live. And it is this beautiful film that really inspired what we're going to be talking about technically today. So let me share my screen. Microsoft has partnered with Netflix to bring unique content inspired by the film. And this is the In Culture page. Let me pop over the link for you all to see if you want to check it out yourself. On this page, you're going to find links to the 3 different modules that we wrote that were inspired by this film. Over the Moon is this adventure about this bright young girl named Fei, and she builds this rocket ship to fly to the moon. Her goal is to prove the existence of the moon goddess Chang'e. And she is just fueled by determination and a passion for science. She really just wants to accomplish the unimaginable. And, you know, I don't know about you, but when I look into the night sky, I don't just see stars. I have questions. What is it that I'm looking at? Is that a star? Is that an airplane? Is that a meteor shower? What's out there? Coupled with stories that my family has told me about the moon. We call the moon abuelita, for example, meaning grandma in Spanish. So how can we know so much about our universe, but not be able to like explore its entirety? And someone like me who's not a space explorer or an astronaut or a scientist for NASA or something like that, how can I, given what I do know and do have access to, how can I kind of curb my curiosity and passion to solve problems that I don't even realize are possible? So when I watched this film for the first time, yes, it's you know, targeted towards children, but it's not just a children's film. It's really just this film about inspiration, and that's what I got from it. And that's why I wrote these modules. So today we're going to be doing a deep dive into one of the modules that we launched. If you want to check these out, you can head over to aka.ms/learnwithdrg/overthemoon, and you'll be taken to these Microsoft Learn modules. We wrote 3 of them inspired by this film, and the one that we're going to be talking about today is the Predicting Meteor Showers by using Python and Visual Studio Code. 2 of my favorite things. So first, we're going to start with kind of a basic understanding of meteors and what we can use, like what kind of data we can use and what we know about our universe to be able to see if we can predict them. I did want to give you a short little clip into what really inspired this particular module. So if you haven't seen the film yet, this is the part of the film that really started to get me thinking, like, ooh, meteor showers, what's that?
Whoa. What in the world?
So it's just a little teaser. In the film, we find out that Chang'e, the moon goddess, can cause meteor showers. So not only are we going to look at real world data and real comets and meteor showers and how those work through this module, but we're also going to think about like how could we add that fictional universe into it to see and try to predict when Chang'e's meteor showers are going to be. I don't know about you, but I really like to pair my technical curiosities with my non-technical ones. So that's what we're going to do today. And yes, to answer your question, this video will be uploaded to the YouTube channel. It'll actually be on channel 9. It'll be on the Microsoft Reactor YouTube channel and the Microsoft Developer YouTube channel. And you can check that out. Let me hide this one. Actually, it's not that one. I don't think I actually wrote one. It's this one right here. So aka.ms/learnwithdrg will take you to the channel 9 playlist of where you can find this. But also, I will be doing other live streams as part of the Microsoft Reactors and on Learn TV. And if you want to check out when my next live stream is, it's not going to be about Over the Moon, unfortunately, but we have a lot of great upcoming live streams, so you can check out when the next one is. Right now, that's still pointing to this one because we're doing it now, but afterwards it'll point to the next one. Okay, so to get started, let's think about what we actually want to do here. So let me go ahead and share my screen again, and I'm going to bring up, oops, wrong side. Oops, where am I? There we are. I'm trying out new keyboard shortcuts and I'm not always the best at them, so apologies. So I'm gonna bring up Visual Studio Code. If you haven't already, I recommend that you download Visual Studio Code. It works on all of your IDEs. And in particular, actually, this is something that I forgot to mention. And let me come over here and do this. If you head over to code.visualstudiocode.com/learn-to-code, which I will go ahead and plop on here so you can see it. If you head over to this site, we actually have, if you're on Windows, a way of downloading not only Visual Studio Code, but also your Python environment and libraries and extensions and everything that you might need to do some Python development. So if you have not already, I recommend checking out the coding pack for Python for Windows. And if you're on a Mac, which I use both interchangeably, depending on which place I'm coding in, you can still download the Visual Studio Code, and then you can head over to the documentation and you can check out under Python the data science tutorial, which is this one right here. And this will help you get set up. So I've already done this process so far. What I've done so far is I have Visual Studio Code installed, I have Python installed, and I have the Python extension inside of Visual Studio Code installed. And what I'm going to do is create a new file in this folder. And just right away, I'm going to save this file. Oops, not that. I'm going to save this file. And I'm going to save it as meteor showers.ipynb. Perfect. Okay. Once I save this as an ipynb file, which is a Jupyter Notebook file, I don't need to do this right now. It'll automatically reload Visual Studio Code to show this Jupyter Notebook version. And we've got some other videos on that, so I'm not going to go into a ton of detail. But basically what we need to know is we've got these cells here and we can run them individually. All right. It is going to be a coding tutorial. We're about to jump into some Python code right now to predict meteor showers given data that we might have available to us. All right, so I'm going to turn this off and we're going to get started on coding this. So the first thing that we're going to need to do is bring in the libraries that we need. And I've already installed these, but I need to import them into this notebook. So I'm going to import both NumPy and Pandas. And both of these are just basically going to allow me to start to do some data cleansing and manipulation, because essentially all of the data to predict meteor showers is out there. We just need to figure out how to properly kind of mix them together. So if I run this, we can see that it completes the run. That's what this, it keeps doing that. I need to fix that. That's what this number 1 says up here in the cell. So it's been completed and I don't see any errors. So that's awesome. The next thing we're going to need to do is import our data. Now, if you haven't seen the modules yet, you can actually grab the data from aka.ms/learnwithdrg/overthemoon/data, and that'll take you to these 4 CSV files, which you can download and save into a folder called data. Once you've done that, you can run these lines of code here. And basically what these are doing is it's using the Pandas library to read a CSV file inside of the data folder, namely meteorshowers.csv, and it's saving that data into a variable called meteor showers. Awesome. So that ran just fine. And just to make sure that we've got what we needed, we can go ahead and start clicking or start doing things like this, which will give us, so .info for data frames in Pandas basically gives us an overview of all of the data that's in this data frame. So for example, in the cities CSV file that we imported into the data frame variable cities, we have 256 non-null rows for all 3 columns, city, latitude, and country. And if we were to open this CSV file and scroll all the way down, we'll see that there are 257 rows because we have the first one being our column names. Yes, I can definitely add those links in the chat, no problem. Let me grab that. So it's just going to be https aka.ms/learnwithdrg/overthemoon and /data and code .visualstudio.com/learn-to-code. Awesome. All right. So that's what's happening with these 3 lines is we're just basically reading in our data. And what is the data that we have here? Basically, the data that we're bringing in is a combination of meteor showers. So these are the meteor showers that we know about. Moon phases. So for example, on January 2nd, we started it had a first quarter moon. And on January 10th, there was a full moon. And then on January 17th, it was the third quarter moon. And then on January 24th, it was the new moon. And all the dates in between there was kind of going through those. The different constellations and where you can see them. So the latitude and longitude of where you can see them. Sorry, the latitude start and latitude end of where you can see them. So if you're on Earth, between those 2 latitudes and you look up into the sky, that's where you can see those particular constellations. And they're especially visible in these months here. And then this is a list of cities and their latitude and their country. And all of the links for where I got this information are in the Learn module. So if you want to check those out, you can. These constellations, some of them are in the northern hemisphere and some of them are in the southern hemisphere. And then the meteor showers, similarly, it's the name of it, the constellation that is its radiant. So where it appears that this meteor shower is coming from, that's what the radiant is. And so that constellation is where it appears this meteor shower is coming from. The best month to see it, the start and end month and day where it's visible, and then the hemispheres where it's visible from. So that's what we're starting with our data. And so we can do these kinds of cities.info and cities.head, for example, to gather an understanding of what our data might look like. So instead of going through all of these CSV files, we can do that with code and with Pandas inside of here. And you can see these are the first few lines of that same one. Cities.head, by the way, brings in the first 5 lines. You could specify something like this, and that'll bring, oops, and that'll bring in the first 10 lines, for example. All right. So if I want to, awesome, I'm glad that you're going to stick around. So if basically what my goal is to say that you are going to, basically, like, let's pretend like I want to write an app where you give me your city and I tell you when the best time to view certain meteor showers is going to be based on your city. Okay. Now we know we have all of that information from all of the CSV files that we brought in, but we want to make sure that our ending data set basically has all of that information clearly, so that it's easy to do, essentially like a lookup. And then that could eventually be used in some kind of machine learning model to do something more intelligent than that. But for now, we're going to just focus on this data science cleansing and manipulation phase, which is my favorite part of data science. So the next thing that we're going to do is, when we're dealing with numbers or with like dates, which are sequential, it's much easier to deal with them as numbers. Because if I want to say, like, is this between these two dates? If I'm looking at July through August for one of the meteor showers, for example, and then I'm looking at that current date, which is July through August, let's say July through September, which is August. It's really hard to know programmatically whether or not August is between July and September. But if I just converted those to numbers, it's much easier to know that. So let's go ahead and do that. First, what I'm going to do is I'm basically going to create this months. And if we printed it out, it looks like this. And it's basically just this dictionary of, hey, this is a string, January, and this is the number that I want to represent that string. So then I'm just going to basically use this dictionary, and I'm going to map that to all of my data frames that have months in them written as words. So then that way they can all be converted into numbers. So it's going to look like this, where we take our data frame meteor showers and we take that particular column that has the month written in words. We're going to map the months dictionary that we just created to that. And then we want to overwrite that same column with the mapping. Okay, so if we did this, for example, and then we did meteor showers head again, then we can see that best month is now a number, and start month and end month are still words. So we can do that for all of them. And yes, I definitely have copying and pasting over here, just in that way you don't just sit here listening to me clatter away on the keyboard. So we can do that for all of them. So it's just the start month, the end month, for the moon phases, the month, and the constellations, the best month. So then that way they're all written in numbers. So if we reran meteor showers.head, we can see that they're all numbers now. Perfect. The next thing that we want to do is Python, and specifically the Pandas library, it allows us to convert things like a month and day into what's called a date time. And that basically will allow us to, again, programmatically be able to know whether or not something's between a particular date time, like a particular actual date, without having to compare day and month and time if necessary. So as an example, we can create a new column called start date. So it's not just the start month or start day, but the start date. And we're going to use the Pandas library to call the toDataFrame function. That'll take the meteor showers start month, and we're just going to do it 2020 because that's the data that I gathered, and multiply that by 100, and then the meteor showers start date, and we're going to format it in this way. So now if we did meteor showers.head, we can see we've got a new column called start date that's got 4/21/2020, which is 4/21/2020. Or sorry, I don't know why I covered that one. And then we can do the same thing for end date. So now we know the dates Can you do that dynamically for all fields with month in name? That's a good question. I think you could do it dynamically for like all data within the data frame that has those keys basically, which is the month. That's essentially a key. I prefer when I'm doing my data cleansing to make sure that I'm being very, very, very specific with what I'm trying to do, because there might be some kind of data in there that's got November in it for some reason, but it's not actually a date. Maybe it's a name of something, and I don't want to accidentally, do that. And there might be a column that doesn't have the word month in it that is a month, and it might get missed. So I prefer to be very, very, very specific when I'm doing data cleansing manipulation, because this phase of data science is arguably one of the most important. Obviously the type of data that you collect and the way that you collect it is very, very, very important. But once you have your data, making sure that it accurately represents the real world and what you know about it, and then you're going to make like decisions and inferences off of that. I think that is like the most important thing, is to make sure that's accurate. So while yes, I do believe there's like a number of different ways you could do that, I prefer to be very, very, very specific about that. All right. The next thing we're going to do is do the same thing to the moon phases data. So we're going to create a new column called date, and we're going to convert the month and day of those moon phases into a date column. So we can see that moon phases.head, for example. It's got month is 1, day is 1, and then we've got January 1st. Next, we had some hemisphere data. So again, I want to convert those into numbers. Handle 1 month following 12 or day 1 following 7. How does ML handle month 1 following 12 or day 1 following 7? I'm not exactly sure what your question is. If you want to try to clarify that one, for us, there would not be a month following 12, because we've specifically said there are only 12 months. In terms of day, I see what you're saying. So if we, okay, let's see. I don't know. Let me just take this. Okay, so the question is like, how would I think the question is, how would Pandas handle it? Because this is just a Pandas function. Machine learning is kind of like the overall practice, but let's just say instead of start month, we had 13. And I'm just going to add some parentheses just to be safe. And instead of start date, we had 8. Oops. Oh yeah, that's fine. So let's just say we had that. Yeah. Error. Is this the right error? Yeah. Unconverted data remains 8. It's interesting it didn't give me the other error. Let me just try. Cool. Converted data remains 21. Yeah, so it seems like for example, if we were to just put 8 here. Oh, 8. That makes sense, because it's not 7 for days of the week, but let's say 32. So it knows, it understands that that date time has certain number of days. 1 month followed. Sure, how to tell the model that month 1 followed. Oh, how to loop around. Cool. Yeah. So this one, we're not actually building the model yet. So it would depend on which model that you're building, but some models will know that. Again, it kind of just depends on what you're building it on. That's a really great question, though. We should follow up on that one. Okay, so we're going to convert everything from northern, southern, or southern into numbers. And now, honestly, I can't remember why I chose to have northern and southern be 3. Don't ask me. I mean, you should. I should look back into that. Why is that 3 instead of just 2? I don't remember, but it doesn't really matter. The point is that it's unique And that's our biggest point. And then we're going to convert these into, rather than hemisphere northern, hemisphere southern, hemisphere northern or southern, into the numbers. And we're going to do that both for the meteor showers and the constellations. All right. And then finally, we're going to do the same thing for moon phases. So for moon phases, we're going to have new moon is 0, third quarter is 0.5, first quarter is 0.5, and full moon is 1. And then we're going to add in a new column called percentage. That's going to be the percentage of the moon that is. But we'll notice that percentage is going to have a lot of null numbers because we only specified first quarter for the date that it is true. And we didn't kind of like lead up into it or out of it. So we'll work through that in just a minute. First, what we want to do is cleanse a little bit more data. So we're going to work through that in just a minute. But we also don't really care much about special events. And now that we've got percentages, we're not really going to care about moon phases. So let's go ahead and drop both of those things. I don't care about the month and day because I've got date, and I don't care about the moon phase because I've got percentage, and I don't care about the special event because in this case, I'm not using that in what I'm trying to do. So we're going to drop those. And then what we're going to do is we're going to basically write a small little program that just says, look, if the current row inside of moon phases, so I'm looping through all of the rows and moon phases, if the current row is null, then I want you to, if the value in the percentage column of the current row is null, then I want you to just go ahead and grab whatever the previous value was. And if we do that, we can see now we have no null values in our moon phases data. You can be much smarter than this than I did. You could have it be like a progression from 50% to 100% and kind of figure out how many of the rows there were in between and do all of that. I just decided to make it simple. The other thing that we need to do is remove all of the other columns that we don't care about. Remember, in our meteor showers data, we created a start date and end date, and we also converted the hemisphere data. So we can go ahead and get rid of those. And in our constellations data, we don't really care about the time of day because the data that I gathered actually just says that the best time is always at 9 p.m. So I'm just going to get rid of that one. Okay, so let's just make sure that we see our data now. So our meteor showers, we've got the name of the meteor shower, the radiant, which is that constellation that matches that meteor shower, the best month, I think I want to remove best month as well. No, we can leave best month because we're going to use that later. So the best month, the preferred hemisphere, the start date, and the end date. For our moon phases, we have the date and the percentage, and that's going to have 365 days in it. For our cities data, we're going to have the city, the latitude, and the country. Didn't really need to change anything for that. And for our constellations data, we're going to have the constellation name, the best month to view it in, the latitude start, latitude end, and the hemisphere, which is now a number. All right. So the next thing that we're going to do is basically create a function that will look up information based on all of this data. Okay, so the function that we're going to create is essentially this. We're going to define a new function called predict best meteor shower viewing, and we want to pass in a city. What we want to return is some kind of string that says something like, in the city that you passed in, you can see the following meteor showers, and then it'll show all of the meteor showers that you might want to see. But we also might want to change that to say something slightly different if, for example, the city that you put in isn't in the list of cities, because I just grabbed the capitals of all of the capital cities of all of the countries, and I didn't gather all cities. So if you wanted to go and add to that data set to gather all cities, feel free to do that, but I didn't do that. So since we know that we want to return some kind of string that's going to be able to print out to the user like all of the things that we want, or that they can see, all of the meteor showers that they can see, let's go ahead and define that empty string now so we can build this up as we figure out what data that we want to include. The next thing is, like I mentioned, I did not include all cities. I am currently in Redmond, but I was born and raised in San Diego, neither of which are on this list. So we do need to first check to make sure that these cities are in the list. So if city, which is the one that we passed in, is not in our cities.values, then we want our meteor shower string to say, unfortunately, the city that you want isn't available for a prediction at this time. And then you'll just return that string. So let's go ahead and run this, and let's just try to test it out. And we're going to pass in San Diego. And then we're going to print this. And actually, let's go ahead and just... Unfortunately, San Diego isn't available for prediction at this time. Okay, so we know that we can capture that, but we do know that, for example, Abu Dhabi is one of the cities. It's the first one on the list. So if we were to put that in, nothing happens. Nothing was returned because we don't have like a else return. And actually, we should probably just add that. Let's go ahead and return meteor shower, oops, string now. So now if we were to rerun this and then reprint this, it just doesn't print anything. None is because nothing was returned. Now we're returning an empty string, which is just looks like nothing. Okay, so thinking back to what we have, we want to give a city, which we know its latitude. We know the latitude of constellations, like the range of latitudes of constellations. And we know from meteor showers which constellations they're coming from, right? So that's how we're going to get to be able to tell you which meteor showers you might want to be able to see from your city. Okay, so the first thing that we need to do is we need to get the city's latitude, right? I'm not expecting a person like I maybe everyone else does. I don't know the latitude of Redmond or San Diego. So I'm not expecting people to put in their latitude. And that's the whole point of using data to help build some kind of app, right? Is that a typical person would have certain amounts of information, like the city that they're in, but wouldn't necessarily have all of that other complex information. And that's where we bring in other data sets to help solve that problem. So what we're going to do is get the latitude of the city, get the latitude of the city from the city's data frame and save that into a variable called latitude. Okay, so from the city's data frame, we're going to locate in the city's column, the city, which is the one that was passed in. We're going to locate all of the rows where in the city column, the city that we passed in is that one. And we want to grab the latitude of that. Okay, so this is basically just locating all of the rows and grabbing the latitude of that city. Okay. Let's integrate with Google Maps. I love that idea. Integrating with maps, that's a really, really great idea. Oh, that makes me want to just go build stuff. I love that. If you do that, if you take this one step further and integrate with some map APIs, please tag me on Twitter at #LearnWithDrG or at Dr. Guthels. Here, I'm going to put those on there real quick. If you do that, like if you enhance this in any way, please show me, because there's so many. That's what I love about this project. There's so many ways that you can enhance this by bringing in like maps APIs, by adding in like a bunch of other cities, by bringing in a bunch of other like meteor showers or constellations or things like that. Like please tag me. I want to see them. That's so cool. I love that idea. Okay, so where were we? Okay, so we have the latitude, right? And again, the next thing is that, so we know the latitude of the city, and we know constellations have a range of latitude from where you can start to see them and where you can stop seeing them. So now I want to bring in only a list of constellations wherein that city's latitude falls within that range. So let's do that. This is a quite a long line, but basically, again, from the constellations data frame, we want to locate all of the rows, and specifically only the constellation column of those rows, but only if the constellation's latitude start column value is greater than or equal to latitude, and the latitude end column value is less than or equal to latitude. And then we want to just make that into a list. Okay. So I hope that makes sense. So basically, locate all the rows, specifically only the constellation column, but only if these things are true. Awesome. Now, there's a chance that there are some cities on this list that I don't have constellations for in my CSV file. So again, we want to make sure that we let people know right away, hey, there may not be any cities, or there may not be any meteor showers available for this. I don't want it to say something like, in your city, you can see the following meteor showers, : nothing, right? That's a poor user experience. So fairly easy. We can just say, like, if the constellation list is empty, if it doesn't exist because it's empty because there was nothing, then go ahead and say, unfortunately, there are no meteor showers viewable from city, and then return it right away. All right, we're getting there. We're getting there. All right, so the next thing that we need to do is, now we know the constellations that are viewable from that city. So now we need to figure out if the meteor showers are actually viewable from that city. So the first thing that we need to do is we need to find the start and end dates for the meteor shower. This is meteor shower start date and meteor shower end date. And this is basically going to go into the meteor showers data frame and locate all the rows, specifically the start date column value, but only if the radiant of the, oh, I totally just missed a bunch of code. I was like, wait a minute, this isn't working. Sorry, we're going to loop through all of the constellations that we've identified. And we want to grab only the constellations, sorry, only the meteor showers where that constellation words. We want to grab only the meteor showers where that constellation is the one where it looks like it's coming from, right? So in the meteor showers radiant column, that means that it looks like the meteor shower is coming from that constellation. So if that is the same, then we want to save that. And then for the meteor shower start date, then we want to save only the ones for that constellation. Okay. Now we are also going to find the moon phases, because if there is a very, very bright moon, it is not likely that you will be able to see the meteor showers because there's too much light in the sky. So on a full moon night, the likelihood of seeing a meteor shower is much smaller. And on a new moon night, the likelihood of seeing a meteor shower is much higher. So we're going to grab the moon phases list. And only for the meteor shower start date and end date, so between the dates of those meteor showers, we just want to grab all of the moon phases between those dates, because we basically want to choose the date within the time when that date is available to see that meteor shower. We want to choose the best time within those dates. Why and operator and not or? Good question. So I think you meant for this one up here. So we have a latitude start and a latitude end, and you know, it's kind of going like this. So we want to only find the constellations where their latitude, sorry, we want to find only the constellations where their latitude start and latitude end, where the latitude of that city falls in the middle of it, right? If we did an or, then it would be anything greater than latitude start, which would go beyond latitude end, or anything less than latitude end, which would also go beyond latitude start. So we want to bound it on those sides. And could you do something like, oh, good question. So I don't think Python allows that. I don't actually know if any programming language allows that. The question is, can we do something where basically we get rid of this and we just kind of go like that? I don't know if any, oh, I'm sorry, I did that wrong. It's like this and that and that and that. But I think that's your question, and it's kind of hard to see, but what we're trying to do there is that. So could you do latitude start, this, and then also that? I'm not actually positive. I don't think there's any language where that is legal, and mainly because this operator is expecting an integer value here and an integer value here. And this operator is expecting an integer value here and an integer value here. And so what would happen is one of these has to be evaluated first, because as powerful as computers are, they're really not actually that powerful, and they have very strict rules. And one of the rules is that you can't do two things at once. So one of these would have to evaluate first. So let's say we evaluated the first one first, then this would be compared to this, which is an integer compared to an integer, but this would return a Boolean value, true or false. And then now you're going to take that Boolean value and ask if that's less than or equal to this. Now, I understand logically, we would say, like, you could pull that apart if you saw that, but I don't think any languages do that. I think they just expect you to do. Oh, it does allow it. Oh, cool. Awesome. Well, then, yeah, it does allow it. But that would be why I would assume that it didn't. And that's why I always tend to, and let me just undo all of this before I mess up. I always tend to just use ands. Again, it kind of goes back to, I want to make sure that whatever I'm writing, I'm 100% positive that that is the result that I want. And for me, I can take this apart in the way I just described by converting this into a Boolean, converting this into a Boolean, comparing Booleans with an and operator, and knowing what that'll evaluate to. And I think that especially when you're first learning, that's really important. And especially when you're doing something complicated like data science, and especially if you're going to share it with other people, because you want everyone to make sure that they're super, super clear. Cool. Okay. Awesome questions. Thank you so much for engaging in the chat. It makes this so much more fun. Okay, so now we're going to, now that we've got the moon phase dates, we're going to choose the best date. And actually, this is not going to be in our for loop. We want to make sure that our tabbing is correct. So for each of the constellations, we just want to choose, we've determined all of these things, and then, oh no, no, sorry. We do want that to be in it because it's for each of our constellations. We want to choose the best moon date within the moon phases list that we just created. So basically, I just want to grab the minimum in the percentage column from the moon phases list because I want it to be the least amount of moon because I want to be able to see it. And then I'm going to grab that date. And then I'm just going to add to my string So meteor shower string, I'm going to add the meteor shower is best seen if you look towards the X constellation on this date. And then we're going to return it. So let's go ahead and try this. Hopefully I didn't make any changes that we can't do. Let's make sure San Diego still doesn't work. Awesome. And now Abu Dhabi should hopefully work. Sweet. So the Lyrids is best seen if you look towards the Lyra constellation on April 22nd. And this one on this date, and this one on this date, and this one on this date. And we've only got about 5 minutes left. So I wanted to add in one little sneak peek of, or like, you know, how I would enhance this a little bit more. We know that the movie Over the Moon came out on October 23rd, and we know when the Moon Festival is. And so we can use that bit of information to determine which meteor shower might be visible. So what I'm going to do is, and this is something that's kind of fun with notebooks, is I'm going to go back to the very top. And just after I imported all of my data, I'm going to add 2 cells here. In the first one, I'm going to add in the Chang'e meteor shower. And I, based on the dates of the Moon Festival, I determined that the, did I get that right? Yeah. I determined that the Draco constellation is likely to show off the meteor shower that Chang'e might be causing based on what she's feeling that day. I highly recommend you check out the movie to understand what's going on there. But, and I'm going to append that to the end of the meteor showers. So let's go ahead and do that. And then I'm also going to do the same thing for the Draco constellation, because the Draco constellation is the constellation. Now, it doesn't help if I run these here, because remember I did all that cleansing. So with notebooks, what we can do is I'm going to go ahead and restart my kernel. I'm going to clear all my output, and I'm just going to rerun all my cells. And when I rerun them, now I've got the Chang'e meteor shower and the Draco constellation in there. So if I scroll down to the bottom here, and this is going to be a little fast. So again, if you are watching this and you want to follow along, make sure to head over to the Learn module to check out how I'm doing this in more detail. But now we've got that extra bit of data. So now we can add in this if statement that specifically calls out that one. So during our loop through the constellations, just after we figured out the moon phases, before we choose the best date, we can say if the meteor shower is Chang'e, then we want to say this stuff. And then else we want to do the rest. I know I'm talking just like super fast and just trying to get this through, but I just want to kind of show you. So we can do that. And then we can run this. And then San Diego still doesn't work. Abu Dhabi. And again, now we can put in Beijing here and say that even though the moon will be bright, the Chang'e meteor shower is best seen if you look towards the Draco constellation on October 1st, which unfortunately we've missed now. But yeah, so that's all of the code. That's how we can kind of combine data it is more straight data. Yeah, thank you, Fuzzy G. Walchme. Yeah, basically we were focusing on data cleansing and manipulation, and that would be the precursor to what then you would use for a machine learning model. And that is what's often missed. We don't often talk about like how you can take multiple data sets and combine them and cleanse them to be able to get information from them. So that's what this module is really kind of focused on. I do want to remind you that we've got a ton of streams coming up. Not just me and the Learn with Dr. G show, but also some of my friends, Megan and Christopher, do streams on blockchain and web development. And we've just got a number of workshops and streams coming from all around the world. So I highly recommend you check out the Reactor channels, either through Meetup, Twitter, YouTube, or by signing up for our email list, which will just send you I think it's like a monthly newsletter, just says, here's all the stuff if you want it. So I really appreciate you joining me today on this stream. This will be on the both Microsoft Reactor YouTube channel and the Microsoft Developer and YouTube channel and channel 9 if you want to check it out. In the meantime, thank you so much for joining me. Thank you for engaging so much in the chat. It has been a pleasure. I highly recommend you check out that Over the Moon film on Netflix, especially if you have kids, but even if you don't, it's just so beautifully animated and one of my new favorite films, as you can tell from my friends here in the background. And if you do extend this in any way, I loved your ideas. There's another one in here about adding in direction and elevation. I love that idea. So if you extend this in any way, shape, or form, please, please, please let me know. Tag me, #LearnWithDrG or @DrGuthels on Twitter. I want to see them. I'm so excited about this stuff. So please let me know what you end up doing. And otherwise, I will see you all in a couple of weeks live and on Friday with another pre-recorded video. So see you all soon. Bye, everyone.